I times T prime, which is the actual infiltration, with what? With the area that is given by this geometric figure here. So the reasoning is, let's create a new curve which starts at time t star, so that the new curve from the time t star to t prime gives an infiltration which is given by the area under the curve that is equal to the actual infiltration until t prime. So the new curve, again, at time t prime, gives the true infiltration that occurs between 0 and t prime. Here the picture is not really well proportionate, because you see the blue area is probably not extended as the orange area. They should be equal. So you should determine T star so that the two areas give the same value. And therefore the mathematical relationship is equal to the integral between T star and T prime of Ft in the T. Where Ft is Orton's curve, starting from T star. So at the beginning, for t equal to t star, you should start with f0, because it's the shifted curve. Okay, so if this is now the good curve, you can move forward with your infiltration until here. And let's call this time step T double prime. Now one would say, okay, I follow the shifted Orton curves, but I say, no, you can't, because again, you have to shift the curve again. So you repeat the similar reasoning, and you shift the curve a bit more. So from here, you move forward a bit, and you go here. And how much should you move forward? Again, you compute this area here, which should be equal to the area here. At this stage, I would say, okay, then you see that the error becomes smaller and smaller. And when you see that the error is so small, at this stage you can say, okay, that's fine. I don't shift the curve anymore. But you may need to shift 2 or 3 times. And you know, if you do the computation by using the PC, it becomes very easy. You have to try with maybe different values of T star, but with the PC you can make as many trials as you want. So you have to try with different shift values, and it's very easy to repeat the procedure how many times you want. There is to say that usually this approach is used at the event scale, and usually when you model a single event, usually it's because you have a very intense rainfall and you want to see what the effect of rainfall is in terms of river flows. So, making it short, very often you have rainfall that is greater than F0, so you can avoid this computation. But of course, if you start from the beginning of the event, the very beginning, the event may start with very low rainfall, and therefore you have to shift the curve because you can't avoid it. If you start with one day of very low rainfall, you have to shift the curve. You can't use the curve without shifting because you would overestimate the amount of infiltrated water, and you would end up underestimating the infiltration capacity. In all this discourse here, in all this treatment, there is an implicit simplification of constant rainfall. Actually, you may have an hyetograph, which is an histogram, which is of arbitrary shape. But the reasoning is the same. You always have to compute the integral, and once that you get a rainfall that is lower than the infiltration potential, you have to adjust the infiltration curve by equating the effective infiltration with the infiltration predicted by the curve. So you move the curve forward in order to match the two infiltration, the actual one and the one given by the curve. Even if you have a very complicated hyetograph, it's not a problem because the integral is a numerical integral, and therefore it's no problem to take a complicated shape of the hyetograph into account. A few words about these coefficients. You can find indications given by the literature. I think also the manual of the engineer gives indication for the coefficients of the Orton curve. But I'm sure that if you Google Orton infiltration, you find plenty of suggestions, and the suggestions for the value of the coefficients also. In alternative, they can be calibrated. You can model infiltration and then give the net rainfall as input to a rainfall runoff model like linear reservoir or time area method. Not IMOD, because IMOD is already taking infiltration into account in its own manner. So you compute infiltration for trial values of the parameters, you give net infiltration as input to a rainfall runoff model, possibly simple, and you calibrate together the parameters of the rainfall runoff model with the parameters of the infiltration model. This is a possibility. And you may, for instance, make sure that the values that you find are not much different from the values that, for instance, the tables, the literature suggests to you. Okay, I would suggest to stop here. And let's meet tomorrow, and we are not using the PC tomorrow. Okay? Bene.